Hi guys, this is our first video in a series of videos that will talk about the configuration of VLANs on Cisco switches. When you think of a LAN, you normally think of PCs, servers, printers, network devices, all connected together in the same geographical location, such as one floor of a building. What you would expect to find at the center of this LAN is a switch, and by default, all devices connected to this switch can communicate with each other, and all of them see broadcasts that are sent by any other device connected to the switch. In other words, all devices connected to the switch are part of one broadcast domain. If you connected another switch to that switch, by default, that switch would just extend that one broadcast domain, so that would increase even more the number of broadcasts that are on that broadcast domain. Before VLANs, we would separate broadcast domains with a router. With VLANs, we can logically separate the switch into multiple broadcast domains. For example, your servers may send broadcasts that only other servers need to see. So if you're sending those broadcasts out to every device and every PC, every printer on that network, it's just a waste. You're sending a bunch of broadcasts, and there's a lot of overhead that doesn't need to be happening because maybe only other servers need to see those broadcasts. So one thing you could do to stop that is you could put your servers in their own VLANs so that the PCs and other devices don't have to see those broadcasts. This is just one example of a use for VLAN, and there are other ways that VLANs can be useful. For example, another useful feature of VLANs is that they group machines logically instead of geographically. Suppose you had machines in different locations that needed to be on the same LAN. Without VLANs, you'd have to physically move those machines all into the same location. But with the flexibility of VLANs, you can leave the machines in separate locations because VLANs can span across switches, and you could group machines logically instead of geographically. So, with that said, let's just take a look at the network we're going to configure in this example. Let's say that next week we're going to be opening a building, or building 1 of our new office. So as you can see on the diagram here, we've got building 1, we've got building 2. And for this building 1, that's all we're going to worry about configuring right now. We've got a new Catalyst 2960 24 port switch. We've named it switch 1. And so when we configure this new office, the first thing we're going to do is we're just going to connect our PCs all to the switch. So we're going to have a local area network here, and our subnet is going to be the 192.168.10 subnet. And for ease of discussion, PC1 is, actually, let me go ahead and explain this. What we're going to do is, whatever the PC is numbered, we're going to make the last digit of our IP address the same, and we're also going to attach it to the same port on the switch. So PC1, the IP address would end in 1, and we'll plug it into port 1. PC2, the IP address ends in 2, so we'll plug it into port 2, etc. So let's go ahead and connect our PCs to the switch. Port 1. Port is Fast Ethernet 02. 3 on Fast Ethernet 03. And PC4 on Fast Ethernet 04. Alright, so now we've got all of our physical connections. Let's go ahead and go to PC1, open up a command prompt, and let's make sure that we can get to the other switches on the network. So first we'll try to ping PC2, and that is successful. PC3, once again successful, and PC4, we've got replies for that as well. Good. All right, so everything's working, so let's go ahead and move on. All right, let's decide that the higher ups have decided they're going to divide our users into two groups. We're going to have an accounting group and a marketing group. And they would like us to put the computers that are in the accounting department in one VLAN and the PCs in the marketing department in a separate VLAN. So what we're going to do, we're going to take PC1 and PC2 and we're going to make those members of VLAN 10, we'll say, and PC3 and PC4 will be on VLAN 20. So let's see, VLAN 10 will be the accounting VLAN, and VLAN 20 will be the marketing VLAN. All right. But all right, before we do that, I'm gonna go into the switch here. We're going to show you a command that's going to show you the VLANs that are configured on our network. So let's go ahead and go into enable mode on this switch. And the command we're going to run is show VLAN. Simple enough. Expand this out so it's easier to see. Now by default you'll see that we have VLAN 1. In fact, VLAN 1 has been configured and all of the ports on our switch are currently members of VLAN 1. And you can see that here. VLAN 1 is known as the default VLAN, and you'll find that on every Cisco switch that you come across. You can't delete VLAN 1, but we can create new VLANs and we can move ports into them. So let's go ahead and create VLAN 10 for the accounting department. So to do that, we have to be in configuration mode. And the command to create VLAN 10 is simply VLAN 10. And let's go ahead and give it a name. Command to give it a name is name. Very easy. So we'll name it ACCT for accounting. Alright. So now we want to verify that command worked. So we're going to run our showLAN command, or VLAN command again, but this time we're going to add brief at the end. It just shows a lot of, a lot of the detail that we don't need to see. It'll kind of get rid of, but we can see here we've still got default 1 or default VLAN 1. All of our ports are still in it, but we also have VLAN 10 with no ports in it. So what we're going to do now is we're going to go back into configuration mode. Now go into interface configuration mode for Fast Ethernet 01, which PC1 is plugged into, and we're going to add that port to VLAN 10. So in order to do that, like I said, we go into the interface configuration mode for that interface, and the first command we're going to run is switch port mode access, and that makes that port an access port. There are two different kinds of ports. There are access ports and there are trunk ports. We'll talk about trunk ports in the next video, but for now just think of trunk ports as ports that you use to connect switches together. We could actually configure this port to be in VLAN 10 without running the command that we just did to make it an access port, but it's good practice to make the port an access port before you do add this to a VLAN. You'll find out in a later video why that's a good idea, but basically it has to do with switches negotiating trunk ports. So you don't want this port to ever, someone to be able to unplug your PC out of that switch port, plug in a switch, and automatically create a trunk. It can be cause security issues. But like I said, that's for a later video. So what we've done, we've made that port an access port. So that port can only belong to one VLAN, and the VLAN we're going to make it a member of is VLAN 10. So the command to do that is switch port access VLAN, and then the number of the VLAN that you want it to be a member of. So it is now a member of VLAN 10. And let's go ahead and verify that by running our show VLAN command again. Now normally you run the show VLAN brief command from enable mode, but if you type the word do in front of the command, do show VLAN brief, you can run it from right here. And we look, there's VLAN 10, our accounting VLAN, and port FA01 is a member of it. So now let's go to interface fast Ethernet 02 so we can add PC to VLAN 10. Once again, we're going to say switch port mode access to make it an access port. And then we're going to run the command switch port access VLAN 10. And we're going to double check that again. Just hitting the up arrow, it'll go back through the commands I've already performed. And there's our showland brief. VLAN 10, FA01, and FA02 are in VLAN 10. And I'll tell you what, now while we're doing that, let's go ahead and just show our running configuration. And you'll see interface fast Ethernet 01, switch port mode access VLAN 10. So we know that's in VLAN 10 also by looking at our running configuration. Same for fast Ethernet 02. Alright, so now that we've done that, let's see, what do we still need to do? We still have to create VLAN 20 and add PC3 and PC4 to VLAN 20. So let's go back into configuration mode, interface FA03. Now what have we already done, or not done? We have not created VLAN 20. But let's go ahead and run the commands to add it to VLAN 20 and see what happens. So first let's make it an access port. And then we're going to add it to VLAN 20. Let's switch port access VLAN 20. See the message we get. It says access VLAN does not exist. Creating VLAN 20. So since we have not created the VLAN 20 and we're trying to add a port to it, the switch recognizes that there's no VLAN 20, but since you want to do it, it goes ahead and creates VLAN 20 for you. So that's a second way that you can create a VLAN. You can create it straight from within the interface configuration mode. So just to verify, we're going to take a look, and there it is. VLAN 20 has been created, and port FA03 is a member of that port. So let's go into fast Ethernet 04, make it an access port, and then add it to VLAN 20. Sorry, that was my phone, if you heard that ding. And there we go. Both of our ports are in VLAN 20. One last thing we're going to do is we want to exit out back into global configuration mode. We're going to go into VLAN 20 and give it the name Mark for marketing. So now it should show up here. There we go. Alright, so let me just take a look at my little checklist here and let's see where we've left off. Okay, so now that we've done that, what we want to do is just do some tests. So let's go to PC1. Remember, before we could ping all of the PCs from PC1. But let's try it now. We're going to try to ping PC2, who we know is in the same VLAN, VLAN 10, and we're getting replies, so that's working. Now what do you think is going to happen when we try to ping PC3? Well, what should happen is that it should fail because that's in a separate VLAN. And sure enough, it is not going to work. And so let's try the same thing for PC4. And it does exactly what we expect. It doesn't allow the ping. So now let's go to PC3. And we'll try to ping PC4. It works as expected because they're both in VLAN 20. And we're going to try to ping PC1. It fails as expected. And PC2 should also fail. And it does. Alright. So the last thing we want to do is we want to change some IP addresses. And the reason is because of this. Just as you would have different subnets for physical LANs, when you think of your logical LANs or your virtual LANs, you should also think of those as separate subnets. So different VLANs should be configured for different subnets. So for VLAN 10, we have subnet 10. Your subnet ID doesn't have to match the VLAN ID here, but it's a good practice because it's it's just easy to remember. Subnet 10, VLAN 10, same subnet. So what we're going to do is VLAN 20, we are going to change our IP addresses. So we have subnet 20. So I actually have to go in here and configure that on the PC. And I'll do the same here. Oops, sorry. Same here. Change my IP configuration so that it is in subnet 20. And just once again, we want to make sure now that we've changed those addresses, we can ping. So there we can ping PC4. Alright, looking at my checklist, it looks like that's about all we're going to do for this video. In the next video, we're going to hire some fictional employees and open up our office in building 2. And for that to work, we're going to have to discuss trunking, which, if you remember, I briefly mentioned that a trunk is basically a connection between two switches. So we'll talk about that in the next video. See you there.